general preparation procedure, general manufacturing procedure. So this is what we had seen in refractories. Okay. So the next topic we start with is the adsorption. The adsorption and kinetics both are the true chemistry topics which you have already studied, right? So what is adsorption? Adsorption is a bulk is not a bulk phenomena. It is the surface phenomena. So what we are going to read in this particular chapter, in this particular topic under the head of adsorption, we will study what is physisorption, what is chemisorption, Cronlich and Langmuir adsorption isotherm, heterogeneous catalysis a little bit, and the heterogeneously catalyzed reaction. Now this PPT has been prepared, and this is a general one for all the section and all the students. So, like whoever has made this PPT, this is common for all the students. Okay, so very first beginning, what we see is how do you distinguish absorption and adsorption? Yes, anyone can tell me what is difference between absorption and adsorption?
Ma'am, adsorption is basically the collection of molecules on the surface, and absorption is basically the molecules get through the another material.
Yeah. So as here you can see, adsorption is accumulation of molecules on the surface, a surface layer of molecules in contact with an air or water phase. Now it is better to say presence of higher concentration of uh, a foreign substance on the surface of adsorbent or another substance uh, is termed as adsorption. So the concentration on the surface is more than the bulk of the gas or bulk of the liquid. Then you call that the substance is getting adsorbed on the other substance or other material. Okay. Whereas absorption is a bulk phenomena where the molecules tend to penetrate in or moves in. So absorption is dissolution of molecules within a phase, within an organic phase in contact with an air or water phase. So this is what a book language says. So adsorption is you have a phase 1. We call this phase 1 as an adsorbate. Just keep in mind this is adsorbate, BATE, and this is phase 2 or what you call adsorbent. So the solid surface generally, because why I say solid is there are 5 types of interfaces. You have gas solid interface, then liquid solid interface, then you have liquid liquid interface, solid solid interface, then you have gas liquid interface. Such type of 5 interfaces are there that has been studied under the head of surface chemistry. So this topic is part of surface chemistry. Okay. Now in among these mostly studied top interfaces are gas solid interface and liquid solid interface. So most of the isotherms and like the further part, you will find either they'll talk about pressure of the gas. The adsorbate is generally means what is more studied by the scientist and has been reported is the study of adsorbate, and that is mostly gas, and that is where mostly you will find things are expressed as pressure of the gas, or if it is a liquid solid interface, then you have the concentration of the solution uh, which is expressed instead of pressure. So either pressure will be there or concentration will be there. So you have like this is one interface, And in absorption, you find that it gets partitioned, like some remain in the bulk of the gas or liquid, and rest of the molecules penetrate inside the other phase, just like your sponge absorbing water. So the absorption part, P is equal to KHC aqueous, that is, it follows an Henry's law. Then adsorption on solid surface. So, like there are different things can be studied. Like you go for studying adsorption isotherm. So, what is the amount adsorbed at isotherm? Means your temperature is kept the system temperature when it is kept constant. Whatever you study regarding amount adsorbed versus the equilibrium concentration or equilibrium pressure. Now, this is your abscissa and this is your ordinate. Now, ordinate is always a dependent variable and abscissa is your i- independent variable. So, the pressure or the concentration is there, and how much is the amount of solute adsorbed, that is studied. So that is termed as adsorption isotherm. Then you have an adsorption isobar where pressure is kept constant or concentration is kept constant, and you measure the amount adsorbed as a function of temperature. So with the change in temperature, how the amount adsorbed is changing. Okay, then you have an adsorption isosphere where the amount adsorbed is kept constant and you measure the change in pressure with change in temperature, keeping the amount adsorbed constant. Okay, so adsorption process. Now, adsorption is a spontaneous accumulation of gas or vapor, or it may be solute uh, um, from the liquid at the solid surface as compared to the bulk. So you have a higher concentration of adsorbate on the surface of adsorbent, that is termed as adsorption. So adsorbent is a solid on which adsorption occurs. Usually it is a porous material of a large specific surface. And adsorbate is, as I told you, adsorbent is always the substance on which adsorption takes place. Adsorbate is a substance which is adsorbed on a solid surface. Now, it is exactly not solid surface, should not be always a solid surface. It is any surface on which you like you find adsorption is taking place. In many processes are there where you will find liquids act as adsorb. Uh, 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 Liquids act as adsorbent, and gas and other liquid acts as adsorbate. Such kind of systems are also there. Okay. Then absorption, a process in which gas diffuses into the solid absorbing medium, or simple way, water by sponge is absorption. And then sorption is both. It is often difficult to find the difference between adsorption and absorption, and that is why term sorption is used. So, in a more simple language, when you see that adsorption is also taking place, that is, the surface is having higher concentration as well as it is penetrating in, both the things taking place simultaneously is termed as sorption. And occlusion is one more term. Occlusion is your gas molecule getting adsorbed on the solid, especially mostly the metal surfaces. We say that it is the occluded gases present over here, over there. So it is specifically your adsorb bait is a gas when you talk about occlusion. Okay, then adsorption process is again shown like this. So there will be some active sites and some general sites. Then what is
Yes.
physis option in chemical?
Ma'am,
Yes,
can
yes.
you please explain option?
Option.
Yes, ma'am.
So when you can't distinguish, like you have some material which is porous, okay, and your concentration, like the chamber, this is the chamber filled with some gas, and a brick is kept which is porous in nature. Now, what you will find that the gas penetrates into the pores, but the concentration of this gas molecules is more on the surface of brick than the bulk of the material. पूरे चेंबर में जितना गैस pressure है, compared to that more molecules are present on the surface. So if more molecules are present on the surface, you say adsorption has taken place, but at the same time it went inside also, so you say that absorption is also there. So you can't say that it is um,
Adsorption
whether it is only adsorption or absorption, both the things taking place simultaneously will be termed as sorption.
Okay.
Okay. Then physisorption and chemisorption. Now physisorption we very well know is due to the van der Waals forces of attraction, and whereas chemisorption takes place due to specific active sites, so that there is formation of certain bonds between the adsorbent and adsorbate. Right. So here adsorption, in which the forces involved are intermolecular forces of the same kind as those responsible for the imperfection of real gases and the condensation vapors, and which do not involve a significant change in the electronic orbital patterns of the species involved. Whereas in chemisorption is adsorption, in which the forces involved are valence forces of the same kind as those operating in the formation of chemical compounds. So you get formation of a surface compound, or the chemical identity of your adsorbate may change when chemisorption takes place. So this will be highly specific and selective, whereas physisorption is a generalized term taking place on a general surfaces, not very specific, and hence the rest of the things are there. Okay, so adsorption, if it is physisorption, you don't have a specific site for it, whereas in chemisorption you have specific site for these. Now you can imagine that if this is a circular one, this is a site for this particular thing. Now you can have a material, different material you can synthesize, which will have this semicircular part also. You may have some groove which is rectangular in shape also. So you can synthesize a material which will have a specific cavity and can absorb that particular analyte also. So one or two multi specific can also be there. Okay, nowadays more research in surface chemistry is going for like you have targeted two things, and both the things should get absorbed in such a case. So that is there. Coming to characteristics of physisorption, it is non-specific in nature. The easily liquefiable gases like CO2, SO2, NH3, ammonia get readily absorbed. It is reversible in nature. Okay, increases by increase in pressure. Surface area of adsorbate as the surface area of um, adsorbent, it should be as the surface area of adsorbent increases, more gas is absorption increases. Since adsorption is exothermic, physisorption takes place readily at low temperature, and desorption takes place at higher temperature. Why? Because at very high temperature, it happens that the molecules attain energy to get desorbed from the surface, and that is why it undergoes desorption at high temperature. So, if you have distinguishing features, physisorption occurs due to van der Waals, chemisorption due to chemical bond, Physisorption is reversible. This is not truly reversible. You may call it as irreversible. Then it is not specific, but chemisorption is specific. Enthalpy is low, whereas chemisorption then enthalpy is high. Then more liquefiable gases are adsorbed. Gases which form the compound can only undergo chemisorption. Then decrease with increase in temperature. Increase with increase in temperature because the number of molecules with activation energy increases. Low temperature is favorable. At low temperature, it is favorable. This is favorable at a moderate temperature or optimum temperature. You call it as not low temperature nor very high temperature. Optimum temperature it should be mentioned. Then high pressure favors physisorption and decrease of pressure causes desorption. High pressure is favorable, but decrease of pressure does not cause desorption. Result in multimolecular layer, and here it results in unimolecular layer formation. No activation energy is needed. High activation energy is needed for physisorption. It is instantaneous, and this chemisorption is a slow process. Again, we come to the same thing. What is the rate? Rate is very fast. Strongly in physisorption, it is strongly temperature dependent. Activation energy, there is no barrier. Activation barrier, generally the activation energy has to be high. This is again the same thing. Surface coverage, this is multi-layer, this is monolayer formation. Highly reversible, often irreversible. Okay. Then applications are determination of surface area and pore size, determination of surface concentration and kinetics, rate and desorption, determination of active centers, and so on and so forth. Examples are nitrogen on carbon or charcoal. Nitrogen on charcoal mostly studied. Then benzene on palladium catalyst. Okay, now again some same thing is there repeated, but here the values of your enthalpy are given 5 to 50 kilojoules per mole. Here it is very high, 200 to 400 kilojoules per mole. Rest of the differentiating points are almost same. And this is physisorption, this is chemisorption. Okay. Now, so what we see, this is what we write, X by M. Now, what does X by M mean? X means the amount of adsorbate, okay, per gram of adsorbent. So, X is the amount of adsorbate and M is the quantity of adsorbent. Okay, so this is X by M. So, X by M, I am very much used to using the term X by M because you specifically you have a segregation. What is X? X is the adsorbate, M is the adsorbent. But many books you will find either they'll use the term Q, QE, and so on and so forth. Okay, so whether it is a gas solid interface or liquid solid interface, always make habit of using X by M. What terms you used when you studied adsorption for the 12th standard?
X by M only, ma'am.
X by M. So it is good. X by M is better way to interpret your all your isotherms and all the information based for your adsorption studies. Okay, so adsorption is an exothermic process. According to Lee-Chatelier principle, the magnitude of physisorption will decrease with increase in temperature. Why? Because the molecules tend to get the activation energy, and as they get energy, like consider some molecules are here, they tend to move away from here after getting, they become uh, more mobile and they are dissolved. Okay, so with increase in temperature, it will go on gradually decreasing, gradually, not very big, steep increases there. For chemisorption, what we find, it gradually, initially with increase in temperature, chemisorption increases. And then after certain point, that is, it attains its activation energy to form adsorbent, adsorbate compound. Then further, if you increase the temperature, that energy is making the molecule more volatile, or evaporation of what you say, like desorption of the compound takes place, or the molecules take place at a higher temperature than this. So the trend is something like this. So we find that the optimum range for chemisorption is certain temperature range, a small temperature range, not be lower than this nor more than this. Okay. Then what are adsorption isotherm? When you correlate the uh, amount adsorbed, okay, with the concentration or pressure of gas, it is termed as adsorption isotherm. So the relationship at a constant temperature between the equilibrium uh, adsorbed amount of gas adsorbed and the gas pressure, okay, is termed as an adsorption isotherm. So we always say that when you are plotting, it is always the equilibrium concentration, or it is the equilibrium pressure. Equilibrium pressure means the pressure after it is getting absorbed, or the concentration of the bulk which is after the adsorption on the surface of adsorbent. Okay, so that is why it will be always like your x-axis is either CE or PE. PE or CE means uh, equilibrium pressure or equilibrium concentration. Then adsorption reduces the imbalance of attractive forces which exist at the surface, and hence the surface free energy of a heterogeneous system is formed. Now you know that if this blue colored box is cut into two pieces, right? Now you know that the metals, say suppose if these are all metals and you have cut the part. Now this part is exposed to like the bonds which were there with the adjacent atom now are open, and that is why the surface has uh, free valencies, right? And that is why adsorption is seen. So many a times it is said that you should have a fresh surface every time, or like your charcoal. Mostly charcoal is the universal adsorbent. We say you use activated charcoal to get the best results of adsorption. That is, you heat it in oven at 110 degrees centigrade for around 1 hour, so that all the occluded gases and all are removed from there. Okay, so that is how you make the surface more active, and then you use it for adsorption. Accordingly, in a solid gas system, the relations expressing energy changes are similar to those in liquid gas system. The main difference in the discussed system is surface heterogeneity with regard to energy. Now, adsorption isotherm, pure gas adsorption. Now, linear isotherm, or a form of Henry's law, Q is equal to Kp. Q is the equilibrium loading. Equilibrium loading is, you can just imagine this is your x by m, x loaded on m. K is empirical, temperature dependent constant for the component, and P is the partial pressure of the species. Okay, this is the partial pressure of the species. As temperature increases, the amount adsorbed decreases because of Le-Chatelier's principle for an exothermic process. So what you find here, the trend is something like this. And when you talk about volume adsorbed per gram of adsorbent, with the increase in temperature, it is going on decreasing. Okay, so the as the concentration is increasing, you find to certain extent it follows first order kinetics. Then the reaction is 1 to 0 and then 0 order. Okay. So Freundlich adsorption isotherm. Now Freundlich in, I think it was in 17, 17 or 1905. Okay. Freundlich adsorption isotherm was put forth, and it was totally based on intuitional logic without any theoretical backing. And according to Freundlich, x by m is equal to kp raised to 1 by n, where k and n are constants, which are temperature dependent constants. N lies in the range of 1 to 5. In general, with the increase in T temperature, N increases, but K decreases, approaching a value of 1 at high temperature. Freundlich adsorption isotherm can be derived by assuming a heterogeneous surface with a non-uniform distribution of heat of adsorption. Fitting of experimental data to the Freundlich equation by a nonlinear curve fit, and by plotting log x by m versus log p for the linear form. So the linearized form of your equation becomes log x by m is equal to log k plus 1 by n log p or ce. Okay. So what we find here, when you plot this, your log p will be on your x-axis, log x by m will be on your y-axis, and the intercept here is obtained here. Intercept on y-axis gives you the value of log k, and 1 by n is the slope. So from the slope value, then you can find out the n value. Right? Once you get the slope value, you can find the value of n. Okay. So this experiment you generally perform in lab to verify Freundlich adsorption isotherm, and the experiment that we will see further is adsorption of acetic acid on charcoal. Okay, so that experiment we have to see later. Okay, so this x by m versus um, log of x by m versus p or ce is something like the curve goes like this. So after certain concentration or certain pressure, at a high pressure, it is almost constant or gets saturated. We are studying isotherm means what is the amount adsorbed per gram of adsorbent,
Okay. Sorry, I'm sorry.
how that is changing with pressure or concentration. Temperature has nothing to do here. Temperature is constant throughout. Mostly things are performed at room temperature for study. And then specific, when you talk about heterogeneous catalysis, like in refineries, in your catalytic cracking, डीजल से आपको पेट्रोल बनाना है तब उस समय में जो like whatever catalyst is being used, that time the temperature and things are considered, and that is used. But this is a Freundlich adsorption isotherm. The temperature is constant. Okay. So what you find here? Here in 1895, it was initially Bodecker proposed an empirical equation for the adsorption isotherm in the following form. So according to this particular scientist, A is equal to Kp raised to 1 by n. where K and N are the constant whose value depend on adsorbent and gas at a given temperature. So you have an adsorbent, that is the solid material, gas, that is the uh, that is your adsorbate. So एक adsorbent पे depend करेगा, एक adsorbate पे depend करेगा. This was the very first equation given by the very first person. Then this equation was again put up by Freundlich, and it was popularized or became popular. Now it is always like this. There are many scientists working all around the world, and they'll be giving their this thing. But one who has a greater trump, their name comes up, and the things are known by their name, and many of the reactions are also put by the name of those scientists who are at who are either the editors of the big journals, and things are there. So that is a different thing. We are not going in detail of those things. Okay, now coming back to this. So Bodecker and Freundlich. Now, Freundlich can be pronounced as Freundlich, Frundlich, Frindlich. The spelling is like this. Okay. Now, according to Freundlich, this was a totally empirical equation based on intuitional logic. X by m is equal to k p raised to 1 by n. And according to Freundlich, the biggest limitation of Freundlich was the k and n values, they change with temperature, and it says that it will go on increasing, but it does not happen. It gets saturated. So they are the limitations of Freundlich adsorption isotherm. The Freundlich isotherm reminds that of Langmuir one. Langmuir came later on. However, it differs by lack of straight proportionality line between the amount of the adsorbed substance A and the gas pressure in the range of low pressure. Low pressure, it is first order. Okay. So Freundlich adsorption isotherm, what we know here is X by M is proportional to P raised to 1. In the middle order, it is X by M proportional to P raised to 1 by N. And towards the end, it gets saturated. X by M is proportional to P raised to 0. So the whatever be the increase in pressure, it is not going to affect the rate of adsorption or amount adsorbed. So amount adsorbed X by M remains constant even if you increase the pressure or the concentration of your solution. Okay. So at low pressure, X by M varies linearly with P. X by M is independent of P at high pressure, and at intermediate pressure, X by M is proportional to P. Okay. Then coming to this particular thing, now I would like to uh, yeah, here only I can discuss. Now you see, even now, in spite you have Langmuir coming up later on. Then surface chemistry was revolutionized by BET isotherms, that is Brunner, Emnett, and Teller. Now, what they gave the five very stringent type of adsorption of nitrogen on charcoal were discussed by Brunner, Emnett, and Teller. We are not going to discuss that. That is all MSc level topics. So we are here to discuss engineering level topic, and that is why Freundlich and Langmuir we are discussing. Now, why engineers are using this? Now, you see, you are using charcoal a lot for adsorption of number of things from drinking water, effluent water, and so many things. That is why this is more of useful. And now also, if you have types of coal samples or charcoal samples, and someone says you, how will you find out which one of the charcoal sample is better? Then your chemistry class you will remember, and you will say, yes, sometime madam had told us that Freundlich adsorption isotherm, although this is the most primitive and old one, still that is a very quick solution giving, and you can find the quality of your material. Now what is done, you go for the adsorption. Now experiment you will perform, that time you will understand. Now what happens, you get one line like this, one you get like this, and one if you get it something like this, say not with a greater slope. Okay, now you have got three charcoal samples. One is like this, one is something straight like this, and something is like this. So to find out which one is the better adsorbent, you can perform a Frohnlich adsorption isotherm. So when you want to determine any like when you want a charcoal sample with a higher log K values, that is generally for say when the solute concentration is very less. Suppose if it is drinking water and you want to remove some arsenic from or fluoride from drinking water, so you will select a charcoal sample which has a higher log K value because that is operative, that has the adsorption capacity it has a greater adsorption capacity at lower concentration. But a charcoal sample which shows you a greater slope, and with increase in concentration, it shows a greater increase in adsorption. That will be better for an effluent where lot of load of like contaminants is there in the water. So such kind of charcoal, you will say, if you are treating some effluent from a factory which contains more of heavy metals, yes, I will choose the C type of charcoal. So that is the application of Frohnlich adsorption isotherm. I don't know whether this PPT covers this or it does not cover this part. The Frohnlich, yes. Yes,
Ma'am?
yes,
Ma'am?
yes, yes.
Means
You are audible.
X upon M is not the highest.
X upon M is
It means it can be absorbed by an adsorbent. It is 0 to the highest value. You have told ma'am last slide.
so what is the problem?
Yes, ma'am. I am just
Should we go ahead? See, your voice is breaking. Maybe my voice is also breaking when, like, if the net is not proper. But like yours, I couldn't hear your sentence completely properly. Yes. Do you still have any doubt? Should I go to the earlier
ma'am,
slide?
I am asking that
X upon M
yes, ma'am.
at 0. Yeah, it starts from here. Here, the concentration of the P is also 0, no? With increase in
Yes,
pressure,
ma'am.
its m will start increasing.
Ma'am, I am asking that ma'am at any constant pressure and temperature. And
At
X
any
upon
constant temperature,
value of X that absorbed and pressure that can be absorbed by adsorbent. May vary from 0 to maximum value. We can take that.
see, I didn't get what you are saying because the voice is breaking. So please repeat your what is your query. I am unable to solve your query.
मैम ये पूछ रहा हूँ मैम कि मैं जैसे एक्स अपॉन एम की वैल्यू हम जितने हम हाईएस्ट मतलब एब्जॉर्ब कर सकता है हम कोई
हाँ हाँ
जैसे हम सॉलिड किसी गैस को तो
हाँ हाँ
हाईएस्ट वैल्यू लेनी है एक्स अपॉन एम की या फिर कोई बीच में से फ्रेश वाटर डाला उसमें तो इतनी क्वांटिटी एब्जॉर्ब की उसने तो यही ले सकते हैं
Okay, okay. Now I got what you are asking. Yes, you see. This is the adsorption isotherm, right? So, like you are trying to study the adsorption isotherm, you can always take this value the maximum value beyond which, because you want to find out how much quantity of loading can be there, right? Are you getting? How much quantity of loading can be there, you want to find out. Then it is always good to take this. But you will see in all applications, you don't need this value. Okay? In many application, you don't need this value. You should always take this value, how much maximum loading can be there by the surface. And that you will get at this point only. Okay, but uh, it is not always necessary that um, what is the maximum loading. You have another term, because this constant k also is there, which is giving you the adsorption capacity, and this gives you adsorption intensity. Now this capacity and intensity are two different constants. So, depending on the application, you have to choose an adsorbent, and your adsorbent will always, like, if you have to rate the adsorbent, you will always see that what is the maximum loading capacity of that particular adsorbent. But it doesn't mean that your log K value or the K value has no significance. It is not like that. Some application will definitely need consideration of your log K value also. Are you getting?
Yes, no.
Yes.
Yeah.
And there are many such application where you need a log K, higher log K value. Okay? Means, you see, if you are having one charcoal like this, another charcoal, the graph starts from here. Now some scale is here, and here itself, this is your log K1, and if this is your log K2, then if log K2 is more, that means at zero concentration itself, at very low concentrations, where your water is having very low arsenic and all, the ability of that this particular charcoal is more to adsorb arsenic. So why you will select this particular charcoal? Why not select this particular charcoal? Isn't it?
Yes, no. That is
Okay.
having
The
more
Front's equation.
capacity.
Okay, we will discuss it during the experiment again. The Frontlich equation is simple. However, it does not exactly describe the isotherm in a wide pressure range. It was rather used to describe adsorption uh, qualitatively. Then the equation appeared to be sometimes useful in theoretical considerations, and it can be derived. It is applicable within certain limit of pressure. At higher pressure, it shows deviation. You know that it shows saturation. The values of constant K and N change with the temperature. And the Frontlich adsorption isotherm is an empirical one, does not have any theoretical basis. That is why then Langmuir in 1916 gave his own assumptions, and assumptions, like he made some assumptions for giving his own hypothesis. So the Langmuir adsorption model is the most common one used to quantify the amount of adsorbate adsorbed on the adsorbent as a function of partial pressure at a given temperature. So uh, the assumptions made by Langmuir were: the adsorbent surface consists of certain number of active sites proportional to the surface area, at each of which only one molecule may be adsorbed. Each adsorbate molecule occupies only one site. There is no transmigration, and in occupancy of neighboring site is like occupied occupancy of one site is independent of occupancy of the neighboring site. No lateral interaction between the adsorbed molecules takes place. Thus, the heat of adsorption is constant and independent of coverage. Then, adsorbed molecule remains at the site of adsorption until it is desorbed. Okay, the adsorption is localized. A maximum adsorption only At maximum adsorption only a monolayer is formed. Molecules of adsorbate do not deposit on the already adsorbed molecules of adsorbate only on free surface of adsorbent. That is, like there is only like whatever is free, there only adsorption will be taking place. So the basis of Langmuir equation for mass action kinetics assuming chemisorption, the surface of adsorbent pores is homogeneous. Then negligible interaction forces between adsorbed molecules was considered. Then theta is fraction of surface covered by adsorbed molecules, and 1 minus theta fraction of bare surface. And the derivation, I think I have, yeah. Now I'll better go with this derivation. Adsorption is a dynamic process where adsorbed layer is unimolecular in thickness. When equilibrium is reached, rate of condensation is equal to rate of evaporation. Gas behaves ideally. Energy of adsorption is constant. All sites of adsorbent are equivalent and surface is uniform. Ability of a molecule to adsorb at a given site is independent of occupation of the neighboring site. There is no transmigration of adsorbate on adsorbent. So you consider that A gas molecules are adsorbed on the metal surface, M surface, or M sites are there, leading to formation of AM. So the initial pressure of A gas is P, and the number of sites of the metal is N. At equilibrium, the pressure is P, and M is like the number of sites are like theta is the occupied sites, n minus theta are remaining. So it is n into 1 minus theta, and what are formed are n theta are the formed one. So rate of desorption is proportional, adsorption is proportional to pressure of gas A and number of vacant sites. And rate of adsorption can be written as Ka, that is Ka n into 1 minus theta, and rate of desorption, that is the backward reaction taking place, Kd n theta. Like this will be like if you write Kd here, the backward reaction, Ka the forward reaction, adsorption taking place. So the reverse reaction is desorption, where Kd n theta. So where n is the total number of sites. So theta is the fraction of sites occupied by gas A. So theta becomes number of sites occupied by the number of sites available. Hence, at equilibrium, rate of adsorption is equal to rate of desorption. You equate Ka-Pn 1 minus theta to Kd-n theta. So Ka-Pn 1 minus theta by Kdn is equal to theta. So this Ka by Kd, you write another constant K. Kp 1 minus theta is equal to theta. So 1 minus theta by theta equal to 1 by Kp. So 1 by theta minus 1 is equal to 1 by Kp. So 1 by theta is 1 by Kp plus 1. So 1 theta will be equal to 1 plus Kp upon Kp. Therefore, theta comes out to be Kp by 1 plus Kp. Now at low pressure, your K into P is much lower than 1. So therefore, theta is equal to P. Kp, order is 1. At very high pressure, Kp is higher than 1. Therefore, theta is equal to 1. Order is 0. And at intermediate pressure, theta is equal to Kp raised to n. N lies between 0 to 1. So amount adsorbed x by m is proportional to theta. So when this amount adsorbed is proportional to theta, you add another constant q here, and when you add another constant, x by m is equal to q theta. So when you write here x by m is equal to q theta, theta is substituted by this value kp by 1 plus kp. Now k is the Langmuir isotherm constant related to the energy or enthalpy of adsorption, and q is monolayer adsorption capacity. So x by m is the experimental adsorption capacity, x by m. So the test for Langmuir adsorption isotherm or linearized form of Langmuir adsorption isotherm is P by x by m is equal to 1 by k to q plus P by q, where P by x by m, when you plot on the y-axis, and P on the x-axis, the intercepts give you value of 1 by k, and the slope will give you value of q. Okay, so this is how you get the various terms, and then you have certain disadvantages of Langmuir model. Now, the disadvantages of Langmuir model are the Langmuir adsorption model deviates significantly in many cases preliminary because it fails to account for surface roughness of the adsorbate. Rough inhomogeneous surface have multiple site types available for adsorption, and some parameters vary from site to site, such as the heat of adsorption. The model also ignores adsorbate adsorbent interaction. No, adsorbate like interaction of the molecules of adsorbate. Okay. Then experimentally, there is clear evidence for adsorbate interactions in heat of adsorption data. Also, it is seen that it is not like monolayer. It has assumed monolayer. Then direct interaction and indirect interaction. So direct interaction are between adjacent adsorbed molecules, which could make adsorbing near another adsorbate molecule more or less favorable and greatly affects high coverage behavior. In indirect interactions, the adsorbate changes the surface around the adsorbed sites, which in turn affect the adsorption of other adsorbate molecules nearby. So, in short, what all assumptions are made that there is no transmigration, there is no effect of occupancy of the neighboring site, and so on. They are all are all found to deviate. Okay. So the fundamental difference between Langmuir and Freundlich is Langmuir model was a theoretical construct while Freundlich was empirical. In Langmuir model, it is assumed that at a maximum coverage, there is only a monomolecular layer on the surface. This means that there is no stacking of adsorbed molecules. Freundlich isotherm does not have the restriction, and it is seen that stacking takes place even in your chemisorption part. That is all. Okay, so you have intermediate number of things in this particular PPT, which you may read. It is the same thing what we had discussed in this particular derivation. Okay, so these two derivations are there, or the
Ma'am,
Langmuir derivations. Yes.
will
Today
you
we will
share this
stop here.
PDF, ma'am?
Yes.
Will you share this PDF?
Uh, PPT PDF.
Yeah, yes, ma'am.
Okay, if you want, I'll send you. But like you
And
see,
that book, PDF, ma'am.
refractories.
Yes, ma'am. Yes.
Yeah. Yes. Yes. And X2 batch, are you ready for the Viva? As such, I am having sore throat. or we can postpone the Viva part. We can have the Viva for X2 batch after sessional. As such, the experiments are not
Ma'am,
X2 batch.
excuse me, ma'am.
Yes,
Ma'am, is there still test on 24th? The theoretical test, ma'am, that you are going to take?
theory part test.
Is it still on 24 or is it postponed?
It is on 27 onwards, na?
24th ठीक रहेगा क्या? आप लोगों को पढ़ने के लिए टाइम मिलना चाहिए.
No, ma'am, give time.
टेस्ट से पहले पढ़ते हैं.
You want time? I know. Because now what we are discussing, adsorption and kinetics, you will not need time to read this part, and this is all the preliminary part of these two topics only. It's not much in depth. You have to go. So I think my test is ready, but it is a
24.
10 marks test only. It can be on 27th or 28th also. So that by that time you will read water treatment, refractories, adsorption, kinetics, everything, and that will be a revision sort of thing for your sessional exam also, isn't it?
Ma'am, will it be
Because
theoretical or
paper
MCQ?
is-
Ma'am,
It will be
24.
MCQ.
No. 24.
MCQ.
Okay,
But
ma'am.
the MCQ, when you get the solution and like if anything goes wrong, then you have discussion. So with discussion, number of things are more clear, become clear, isn't it? Now what I found is the Viva which I took for X1 batch, then the next batch was much more prepared. Then the next batch who will come will be still more prepared, right? So
Ma'am.
24th test I may take towards Friday.
Ma'am,
Yes,
ma'am, take it today only now.
Viva. Okay.
Yes, ma'am.
Okay, so 1:30.
Yeah, okay.
Okay, ma'am.
Ma'am,
Ma'am, what is the
Yes.
syllabus of that test?
as the mid-sem schedule is out, so what is the format for chem exam?
Chem exam is like you will get a question paper in which you have like first part will be your like there will be one mock test, mock exam will be there where you will write your undertaking and handwritten undertaking and you will submit regarding the unfair means and if you go with this and that. So that will be submitted and that remains common for all the subjects undertaking, okay, during the mock. And then when the exam is there, every time you have to give a confirmation form. So the confirmation form is out half an hour earlier. So everyone has to be ready half an hour earlier. If the exam starts at 11, 10:30 the confirmation form will be out. So every one of you have to fill that confirmation form properly, roll number, name, and the things that you have to mention there. And that should be submitted within 15 minutes time. Every student has to submit that. Okay. Then by 10:45, when all the students submit, we come to know, or all the invigilators come to know that you have submitted. Secondly, you will get a link for WebEx video, keeping your videos on. Okay, so like you have to keep your video on when you are writing your exam. So videos are generally turned on before the exam starts or the question paper is out. Question paper is generally out exactly at 11 a.m. and 5 minutes prior, your like respective coordinator will ask you to put on your cameras and you should be sit with your answer sheets and your name and roll number written on it properly and you will get time once the question paper is out. Question paper will be there. It is a descriptive paper like short answer, long answer, numerical, give reason, all type of answer except MCQ for sessional. And then you have to you write for 1 hour. After 1 hour, the course coordinator will be after you. Now the time is up. Stop writing and scan the answer sheets. So if it is numbered and named properly earlier only, then you can scan it there itself, and proper name to the PDF has to be made, and you have to upload into the classroom or the link provided.
Ma'am,
Okay.
how many questions will be there in exam?
Exam 25 marks. So 25 marks, like 2 question for 3 marks, 5 question for 2 marks. Okay. कितना हो गया 3 plus 10 16 हो गया, then 9 question, maybe 1 mark question,
मैम मॉक
something
में
like this.
पूरा ही सिलेबस आ रहा है ना?
Yes.
मॉक में पूरा ही सिलेबस आ रहा है ना?
कौन सा syllabus?
I mean, mock test, we will get the whole syllabus now, from water treatment to
No,
kinematics.
test is not for any test. It is only that students are able to connect with the DEC, students are able to join the examination, are they able to put on their camera. Mock test में कोई test नहीं होगा. There won't be any questions asked to you in the mock test. Mock means it is the mock exam just to ensure that, because many students are in villages, right? In India, like there are many rural parts where connectivity is not good. In such case, the student has to consider as if he is in college and he has to move to a better place, better connectivity. So, okay, are you getting what I am saying? That is why a mock is conducted. Mock is only to ensure proper connectivity, students are following, students get to know the rules and regulations. And if a student is in a remote area, he, जैसे 10:30 बजे एग्जाम है, he will come to a place, will pay for that or whatever, he will ensure that he is able to upload his answer sheet. Things are clear.
Ma'am, will there be options in questions like do any one of two?
No, there is never a choice. Be in the exam paper, but for sessional तो कभी 1 mark का भी choice नहीं आता है. There is never a choice of even 1 mark. For sessionals choice नहीं रहता, but you never know when the pattern will change. It depends on like those who are setting the question paper. Any other query?
Ma'am,
Ma'am, question
Yes.
paper will be provided on Google Classroom, no?
Question paper will be provided on Google Classroom. Google Classroom नहीं, आपको मेल में आएगा.
ma'am,
किसके मेल में प्रॉब्लम है? Is there anyone who has problem in there? Then
Yes, ma'am,
I
will
wanted to know
recommend.
who is roll number 50. Is 50 present in this class today?